So thank you very much for the invitation to come here. And as I get older and tireder, I think the gift of our presence to come together to talk is such a big one in this in our busy lives. So I'm very grateful to you all, friends, old friends, and people I don't know yet, for coming along to hear me talk about my projects. This is based on a chapter of my book project, and I want to tell you a little bit about it before I plunge in. I'm looking at the history of ocean work done to develop scientific studies of the oceans in the 1920s, mostly a little bit in the 1930s. And so this is, sometimes you would label this as history of oceanography, but oceanography is a discipline that is actually developing in, as these expeditions and work that I'm looking at are taking shape themselves. So it's a little bit inaccurate to say this is a history of oceanography. Really, it's a history of sciences done on and in the ocean in order to understand the problems that the oceans pose for in two kinds of ways that are interesting to historians of science. One is that the oceans are really difficult spaces to observe in, that they are inaccessible to humans in a lot of ways. And the other is, I think, more interesting for this particular audience, that oceans are a global space, are one of the places where science develops its ideas about its global reach and what the global even means. And that's part of its claims to scientific authority, but it's also something that they construct for themselves, this idea of what it would mean to study something on the scale of the whole world. And that has technological dimensions, that has observational dimensions, but it also has very obvious and specific political dimensions, of course, as well. So often in the history of studying the ocean, we look at, we have focused really on two different kinds of two different periods and skipped over the period that I'm interested in investigating. So there's quite a lot of work done in 18th and 19th century, these voyages of exploration, and I've done some work in that on 19th century hydrography and the work of the Beagle voyages. And then we know increasingly quite a lot about the time period when the oceans became these modern political and military spaces, the oceans of post-World War II era, post-1945. And there are lots of really good reasons for this, the concentration of our historical and social studies of science attention to the post-World War II era, but I think that actually the ideas about what is global about the oceans in both its epistemic and its political sense emerge in this earlier era that I'm interested in the 1920s. So that's why I'm interested in this period, and I want to just present to you some arguments about the work on the oceans in this era by looking at a case study of marine meteorology as it was developing in the 1920s. And what I'm going to suggest is that meteorology is one of these areas of research that that develop this intellectual ideal of globalism in a way that's particularly clearly energized by key technologies that develop in that era, and you probably already have an idea of what they are, but the most important is radio. And then it's also, the other argument that I want to make is that this struggle to develop this scientific sense of global meteorological work is very tied up with political ideals of what scientific internationalism is in the 1920s. So that's the shape of the sort of big picture shape of what I want to talk to you about. If you're interested in STS, this work relates a little bit to the kind of, I don't know, bandwagon at the moment almost of interest in what's called infrastructure, which is actually a term I thought I should explain more after the budget yesterday, but we will maybe, if anybody is interested in how this work connects to the infrastructure interests, I can talk about that in the questions. So what I want to do specifically is talk to you about two projects that develop in the 1920s to develop networks to exchange meteorological information on the oceans. And the oceans have been this space, of course, where observations are difficult to collect and tie into the weather networks that were very well developed by this point on land. And then I'll talk about how to interpret the networks, and then I want to look at how this ties up to these debates about scientific internationalism that are part of the history of the 1920s, the development of particular kinds of debates about internationalization and the League of Nations' role in supporting that as well. Okay, so the two networks that I'm interested in are French and British. So it's a contrast in a way between two styles two national styles of science that will be familiar to historians of science that look at other kinds of sciences in those two countries, Britain and France. So the French one is a set of voyages that were run from 1920 to 25 in a ship called the Jacques Cartier that was a training ship for merchant marine officers. And the British one is a very different kind of network established through the auspices of the Met Office in Britain was staffed by voluntary observers who contributed their data to the British. Okay, so the French case is again dealing with a problem and an opportunity in meteorological networks. The problem is that there are these vast spaces of the Earth's surface that are covered with water, in which it's hard to establish permanent stations to send the data back to the central offices that then can collect and analyze weather patterns as they are emerging. So whether national weather services always face this problem of where the limits of their territory meet the oceans, and then the oceans are this famously blank spot on the global pictures, or any kind of larger than large-scale picture of weather events. So that's the problem. The problem is the oceans as a kind of blank spot in the data collection work of meteorological studies, and the development that poses new possibilities here is the development of radio after World War I in particular. So radio comes, as you probably are aware, starts earlier than that. Marconi's experiments are at the very end of the 19th century, and radio communication takes shape in the first decades of the 20th century. But it's really only after World War I that really highly developed infrastructures for radio start to make radio communication more and more standardized and normalized, and start to extend the range of radio transmissions such that they can be really useful for this kind of work of bringing data to a central point so that it can be understood. So knowing that radio was this new way that the oceans could cease to be these blank spots in our picture of the world, there's increasing interest in how to bring ships into the shipping and ships into the networks and scientific networks after World War I. And the French service was one of these methods. And they equipped this training ship for the merchant marine with a couple of meteorological officers, professors of meteorology that went out and trained these officers. And they started to run these voyages back and forth from France to the east coast of the U.S., and then increasingly further than that over to the west coast of the U.S. as well. You can see by this map that they're going all the way up the west coast of the U.S. before turning back on these long kind of training voyages. And the claim here is that, as the French meteorologist put it, that this ship, even as it goes just back and forth across the Atlantic, will give Paris and the French Central Office of Meteorology two oceans at once, because by transmitting and collecting and transmitting the data from the east coast of the U.S., they have access not only to the east coast of the U.S., but everything that's collected across the continent by the U.S. authorities, and that includes, by this period in the 20s, this includes data from the Pacific. So they're able to argue that they gain with this ship that can move more easily as a kind of floating mobile observatory across the Atlantic, that they can gain not only the Atlantic but the Pacific in their transmitted observations back to Paris. And they collect, as they're going in this sort of floating observatory, they collect data from other ships at sea as well and transmit those back. So there's this sort of regularized exchange of collection and exchange of information that they send back to Paris. And what they end up suggesting to their reasoning about this work that they're doing is that this gives us a real kind of globalism, a real grasp of the phenomena of the whole Earth in a way that has not been possible for meteorologists before this. And they say that this ship, the work of this single ship, gives the meteorologist the globe and its atmosphere in his hand, so he can hold it in his hand like a child would hold an orange in his or her hand. So that's the sort of fantasy of complete knowledge as it's expressed in this lovely image of the orange in the hand in the 1920s. And for the French, it's achieving this globalism is through the means of this centralized floating observatory that is going to be staffed by experts and is going to be this kind of intermediary between the North America, South America, and the heart of the European science, which for a Frenchman is obviously Paris. Not just Paris, though, it's actually the Eiffel Tower. So by this period, the French, and again, this has to do with the history of radio, because the French developed the Eiffel Tower as a radio transmission station in the first decade of the 19th century. And one of the first things they do with this special, rather convenient radio transmission tower is send out weather information. So time signals, as is the main purpose, main scientific purpose of the daily signals that the French send out from the Eiffel Tower, but this becomes very quickly, almost immediately tied up with broadcasting weather information. So this happens, and it gets standardized. These signals and this transmission service gets standardized right before the war, around 1911, 1912. So by 1920s, when scientific work is picking up again after the war, that the arguments about the Jacques Cartier and the significance of its way of reaching out beyond Europe to collect the new world and bring it back to the old is very much tied up with the centralization and the prestige of a scientific signal coming from the Eiffel Tower. So that's one of the little intricacies or curiosities, I would say, of this story, is that meteorology, which is one of the most notoriously imprecise sciences, right? You're even today the best guess after 3 or 4 days of out from today is a notoriously imprecise measurement or estimate, gets tied up with what is, on the other hand, one of the most precise branches of scientific work, which is the signaling of time. So it's kind of a curiosity that both the most imprecise and the most precise of the sciences gets tied together in this transmission effort from the Eiffel Tower. In 1912, when this becomes formalized in an international conference on time, Britain publishes this book, which closes with the comment that from 1912, Greenwich time comes to London via Paris, because it's the radio signals from the Eiffel Tower that are determining international standard time from 1912 on, and weather gets tied up with that. So that's the French model, this very sort of centralized and centralized picture, staffed by experts who are going to go out and do this collection work and be the sort of mobile proxy center that's going to send stuff back to the Eiffel Tower. The UK, the British model has a very contrasting style. So it's built on a completely different idea of a network that is much less technologized and centralized, even though it still depends on technologies in very key ways that I'll explain. So the UK model is that the Central Met authorities in Britain will recruit and not train, but manage a set of volunteer observers, a kind of citizen science of the 1920s, and that they will categorize them with different levels of authority and based on the kinds of instruments and the frequency of transmission of their data. And they will collect all this information from these ships together, but it will come in randomly. It will come in simply during the voyages of these 500 or so observers. And so as these ships, whose captains or officers happen to be within this cadre of voluntary observers are sailing, they will transmit back to London, and that London will gain the oceans in this way, in this much less systematic way, but in their view, equally global, right? Because of the dominance of British merchant shipping, merchant marine. There is, Britain can plausibly make the argument that its ships are covering the globe in a way. So, but you can see the limits or sketchiness of that kind of claim in this image here, because the little dots are the ships that are how the numbers, these numbers and crosses represent the data points that are coming in on June 1st, 1927, and you can see the clustering of them in the North Atlantic, particularly. So it isn't really a kind of evenly distributed picture of data collection at all. But the argument still is that through this voluntary measure, that the British can collect this data. So this British model, then much less centralized, much controlled in a quite different way, but equally technological in a different sense, in that the British, as part of this system, developed the earliest computing methods for sorting and retrieving data efficiently from ship's logs using the Hollerith computer. So they were the place where the radio gets tied to this other key technology of the early 20th century, the early card sorting machines. I don't know, some of you will probably maybe remember the look and shape of those kinds of cards that you hole punched in early data sorting exercises. They are basically developed in the very early 20th century, really around the same time as radio. So they get pulled into the work here as well. So this is the picture of global science that the British can offer, that they will redeem this sort of bank of data that they have from past ship log collections and present data that's streaming in from their system of voluntary observers. And they will have this new technology that allows them to actually make use and manage the information, the data that is coming in. Okay, and they, as you can see, they do it, both Britain and the other agency that does a lot of this work is the Dutch one, based in Holland. They do it with labor of women, transferring this data onto punch cards. So the British system has one other kind of interesting element that the French does not, and that's a sort of journal that that is designed to build up the morale or sense of community, really, not morale, the sense of community of this observing system. So that's for me one of the interests of the contrast between the French and the British. The British has a much more highly developed sense of what the labor is that goes into building an observing community, and it's not enough to be quite as technocratic and centralized as the French model of the floating ship, that you have to do a lot of work to make humans want to engage in this system that you're building up. And the British do it through this publication that they start to publish in the 1920s, which is a really wonderful sort of set of popular science, where they introduce lots of information about things to do with marine science, but also things to do with other sciences, just a sort of general reading for the layperson at sea, combining that with developments, descriptions of technological developments in radio, so that giving the most up-to-date information about this very rapidly developing technology through the 20s and 30s. And they combine that with a kind of publication of information that they get from the observers themselves. So a kind of effort where they're educating their audience, but also giving their audience a chance to record their own kind of observations about the environment themselves in this journal. So you get, again, very differently from the French model, you get an understanding in this journal that scientific observation is qualitative as well as quantitative, that it's data dissemination and data collection on the one hand, but there are also things to do with eye observation that are not easily captured by quantitative data, and that there has to be a place in the observational scheme of things for those kinds of records as well. So it gives a kind of picture of their ideas about what science should be and how it coexists with technological developments, with ideas about eye observations versus instruments and their value, and how much work, how much labor there is in building up both a human and a technological network. And it's very tied, the British case, if the French case is tied to the Eiffel Tower, the British case is tied to the Commonwealth, and the development of the ideal of the Commonwealth as a particular version of global authority in the 1920s. And this is this famous picture of how Canada figures in the global, in the Commonwealth economy, which I always find very ironic, since the main thing that they actually are shipping to Britain from Canada in the 1920s are apples, not pigs. And of course, they're certainly not shipping bisons. So I don't know why I don't know what was going through the illustrator's head when he's making this image. But this whole picture of the world as something that can be managed and envisioned under the framework of a commonwealth of nations, which is and of course through the a kind of refiguring of the old British Empire for a new century, is really, really important version of the idea of the global authority politically that feeds the British experience very much. So what's going on then in terms of making the comparison explicit? For the French, the system that they develop to study the weather systems as they can be observed over the oceans really calls upon an ideal of a centralized authority. They see that ship, the Jacques Cartier, as a floating observatory, a kind of proxy center, a proxy Paris central meteorological office that can move around on the ocean, but move around as a specialist center, move around as a place of specialized instruments and specialized abilities that are going to be truly scientific then, because of that, because that they are a real observatory, not just people with instruments. That they can control the challenges of communication expenses in getting the information efficiently from North America, say, or South America, or the Far East areas of the Pacific. They can control the expense of that kind of work by developing a relationship that is direct and nation to nation, and their idea of what will be the most important relationship financially and politically and in terms of information centers is to link Paris and Washington, D.C., so that they will build up this nation to nation connection through radio mediated by the Jacques Cartier voyages, and through the relationship with Washington, they will get the west coast of the US as well, and increasingly all the claims that the US is starting to make for control over the Pacific will feed back through Washington, D.C. to Paris. So it's very much this vision of a nation-to-nation link, and they're setting up this system in particular to support. I haven't talked very much about the other technology that's behind this story as well, but I can, again, in the questions, that they're supporting. They're seeing their work as supporting aviation, but that they are also going to pursue independent research projects while they are traveling on this floating mobile observatory, so that the observatory can be a center of research as well as something that's going to just help people do forecasts. And rhetorically, this depends on the idea of the ocean as a kind of placeless place. That famous idea that the ocean is a non-territory, is empty space, and intrinsically international then by definition, not a kind of commons, although they don't use the language of the commons particularly. And the French phrase that they use is that it's fatalement international, so that it's what is fatalement? Inevitably or inexorably international. The UK or British model is a model of distributed expertise. So still technologized, still linked to the radio, to the Hollerith computer system, and to the support of aviation just as much as the French case, but based on floating observers who are going to participate voluntarily. And the way to control the expense of modern communications is not this sort of direct line connecting nation to nation, but to coordinate and educate your observers, your what we would now might call your citizen scientists. And it builds on a different kind of precision, it builds on a different kind of rhetoric, two different kinds of rhetoric in comparison to the French ideas about the ocean. The British rhetoric about the ocean sees it as a space for empire, that it's a historic space that Britain has controlled and mastered before and will continue to do so. Through the Navy, through trade, through exploration, and through this system of voluntary observers is just going to layer on to a long-established human history of experience with managing the ocean's challenges. And it also builds on, in terms of scientific ideas about observation, it builds upon a long-standing idea in science in Britain that you can be too precise, that you can be excessively precise in certain kinds of environments. And this, the environment of the sea is the sort of poster child case of excessive precision, where you can, it's actually not that valuable to have all the expertise and high quality instruments of a floating observatory like that on the Jacques Cartier, because there is very limited value to that kind of exactitude in the turbulent spaces, if you like, of out in the field, on the sea. So it's building on these kinds of different rhetorical traditions that are both about science on the one hand and about Britain's dominant relationship with the oceans on the other hand. And they are both trying to make the claim that they're in these years, the 1920s, that their way of dealing with the ocean should be the dominant model. So they're very self-conscious about themselves as alternatives to each other, and trying to not fight it out, but trying to assert the different models very much in distinction to each other in the 1920s. So how does the scientific internationalism issues play into this? Well, it's because of who they are trying to convince to adopt the models. As these two examples of how to make use of the oceans, the scientific possibilities of the oceans are taking shape, the international meteorological organizations, the IMO, is trying to develop standards for international data sharing, international weather prediction services, how nations should go about contributing to the expense and purpose of meteorology on a transnational scale. All this, these efforts to find agreement about the shape of work done on an international scale are being undertaken within under the auspices of the International Meteorological Organization and the French and British cases are trying to be the way that trying to be adopted by the IMO, trying to persuade the IMO that theirs should be the style that's adopted. And the ocean is a particularly important place for these kinds of debates as they take shape. So these kinds of debates about how international data should be shared and produced are taking place on land as well. But the question of how to organize one's work internationally has special dimensions when it comes to the oceans for scientists. And that has to do in part with the history of the oceans as a space in which was organized internationally. So there had been these successful cases, this successful moment in the early 20th century in which the countries had come together through the law, the post the Titanic collapse, to coordinate and agree on how to manage radio communication at sea to give priority to safety concerns. So the Safety of Life at Sea agreement is developed after the Titanic disaster of 1912 and signed in 1914, never actually carried into effect because of the intervention of World War I, but it becomes reinstated, reformalized in the 1920s as well. So this pattern or previous success in internationally coordinating matters on the surface of the ocean is an influential model for meteorology in the 1920s. And then the second aspect of the ocean's importance or significance is obviously the comment that I already mentioned, the idea that oceans are this kind of commons that as a natural environment lend themselves to coordination, to internationalism, as the French claim in 1926, that it's impossible to compartmentalize something like the oceans, that you can't divide the oceans into sectors relevant to this or that particular state, country, or institute, that it's this inexorably international space. And I want to underline that claim in 1926, that it is this impossible to compartmentalize, because it's not in fact what happens. What the specifics of the internationalist debate within the IMO also can break down interestingly into French and British attitudes. So the French attitude to the international organization of the science was that it should develop its programs into a kind of internationally cooperative research structure, that it should formalize its relationships amongst countries, that it should formalize the amount of funding that comes to it, and it should be funded by the state. So it's very much the French model that develops after World War I is kind of like the WMO model that actually takes shape by in the late 1940s and 1950s, that countries should sign up, subscribe, and fund global meteorology, because it's a science that can only be properly pursued on this kind of scale. And this is Delcambre, the French head of the Met Office there, pushes the League of Nations to become engaged in his arguments for what kind of science meteorology could be, and it collapses in a sense on the fractured relationships of post-World War I science. The Germans and Austrians and the Dutch and the British are hostile to the French plans to tie modern meteorology to the League of Nations, to the Committee for Intellectual Cooperation, and quite reluctant to make it based in Paris. And in fact, the offices of the IMO in this period move around quite a lot in Europe. The UK model is a little bit different. The head of the leading figure in UK meteorology is much less interested in this formal structure that the French are interested in pushing, and much more interested in how you can actually start to project a global picture of the atmosphere. How can we make real our claim that meteorology is something that has to be studied on this largest possible scale? And what should the IMO do within this? And he was really reluctant to encourage more state funding in a way for the IMO because he thought it would lead it to be tied more and more closely to the political interests of states if it was funded by the states. If it couldn't be a kind of voluntary international research center, then it would get co-opted, coerced into serving the national interests of its member states too much. Okay, so these different ambitions for the International Meteorological Organization and different concerns about its future direction are very interesting to read because they kind of prefigure a lot of the debates that we see about international organizations in the second half of the 20th century and today, that this problem of the relationship of the states to international scientific projects. All right, so these debates about which way forward the international organization should go are kind of developing in parallel with the push for making the oceans a part of meteorological science. And so choosing which model to adopt, the French or the British, becomes then a political choice about how one should ideally organize a global science. And to cut a long story short, it's the British model that's endorsed eventually at the end of the 20s by the IMO, and not the French model. So in the 26 to 29, the Jacques Cartier trial voyages have stopped, but the question of whether they should be reinstated under the auspices of an international organization is the real question. They decide that they should not, and that we should go with this distributed expertise model of the British case in 1929. But ironically, even though they make this agreement, something much closer to the French model of floating observatories and centralized sort of proxy centers in the oceans of expert observatory sites develops by the late 1930s. So the story is on one level that the British model wins the debate, that distributed expertise and a voluntary model will build up a global science more effectively. And then, in fact, what happens in practice, not on the ground but on the sea, is that something much more close to the French model that was proposed begins to take shape. And the reason for that is really that the science does get, through the 1930s, co-opted more and more by a different technology and serving the interests of that technology, the technology of aviation. So the states, as powers that want to develop their air traffic, do begin to coerce and force a certain pattern of scientific projects on the ocean, and support fixed or more or less fixed outposts and floating observatories, rather than a distributed expertise on the British model. You can see, if we go back to the picture of that this kind of scattered data coming in just as it happens to be fit with the voyages that are going on for shipping during the regular course of the shipping networks, is different from a set of spots in the ocean that can be relied on to disseminate data to aircraft. So it's a very much more scattered model, and doesn't suit the realities of the ocean as not a space just for radio, but a space over which airplanes are going to travel. So that's the second technology that steps in and begins increasingly to shape the reality of dealing with the oceans as both a scientific space, as a technological space, and as a space for eventually war as well in 1945. So that French argument that the oceans were inexorably international and could never be divided up into zones or territories associated with one nation and another, just because of their intrinsic natural qualities, starts to come undone in the 1930s due to stations that are set up in the Atlantic and the Pacific to support aviation, but that tendency is intensified and cemented almost in wartime with a kind of layered network of weather ships that are established throughout the Pacific to distribute information for the purpose of aviation. And what happens increasingly after the end of the First World War is that an international ocean stations are set up and funded by different countries. These weather ships are managed by a whole series of different countries under an international agreement after 1946. So the ocean does in fact get divided up into these zones as a result of the changes in the years between the wars, and especially right after, until you get something that's, it becomes quite commonplace to see something of this sort, where the oceans and the idea of the oceans as having national or regional zones becomes normalized through that. So this is a kind of story of both an ideal about what kind of networks and communities behind those networks that should build the global science, this science of meteorology that covers, that needs to cover a space larger than that of territories, but at the same time, the very technologies that are making it possible and increasing the interest in developing that science over these kinds of spaces are the forces that undo the claims that this is a unique kind of transnational, internationalist kind of space in the end. So maybe I'll just end with that image there, which is our modern oceans, our modern sense of how these spaces are divided up and how information is exchanged within these spaces as well.